Okay, hello. Thank you for the opportunity to bring my presentation here today. My name is Guillermo Camacho, and I'm a PhD engineering student with the Electrical and Electronic Engineering Department at Univalle at Cali, Colombia. And I'm here to present the research entitled Visual Tracking of Objects for Augmented Reality in Interfaces Impacting Operations, a review. I would like to begin by sharing with you a personal story. I saw this picture in a journal about 6 years ago. In it, a person is using a virtual reality device during the process of packing boxes. At the time, I was working on automating box packing, but using computer vision and using industrial robotics, as you can see it in this picture. The first picture was quite inspiring, since it could solve several of the battery limitations that I had identified in my approach. 2 years after this, I finished my robotics project and I was able to begin my doctoral project. For the time, virtual reality had shown poor performance in box packing applications, and what we currently know as augmented reality had entered the scene. It was then when I decided to get an insight into the real usefulness of this augmented reality in an industrial process, such as packing of cargo or packing of boxes. Today, I will show you my field results on this purpose. So let's start with the outline of our presentation. This presentation is divided in 4 sections. The first one is the introduction, and there I'm going to present the problem and locate the problem in the process. So let's begin with the introduction. The industrial operation known as packing is a relevant operation in logistics chains due to the effects it has on four factors. A bad packing process increases the final product cost, increases the delivery times, and reduce the customer satisfaction. And last but not least, increase the environmental impacts of the process. But you must be asking yourself, what is a packing process? Well, there are multiple definitions for this one. We take as reference the next one. A packing process consists of assigning the cargo to a specific position and orientation within a container in such a way that a cost function subject to certain constraint is optimized. This is a complex task, but currently there are applications based on complex optimization routines that allow computing the optimal loading pattern, and with this, they provide multiple benefits to the logistics operations. The result of this optimization process must often be communicated to a human, to an operator, in search of manually stack all the boxes over the pallet on the container. The interfaces that currently communicate the optimal solution to the operator are based on instructions printed on paper or on portable devices, portable screens. These alternatives have been assessed as low efficiency options, especially because of the constant interruptions of the process due to the alternation between the paper and between the cargo that the operator is manipulating. Several authors have identified in mobile augmented reality an opportunity to improve the interface that communicates the building instruction of the pre-computed solution. These explorations have concluded that using augmented reality with head-mounted devices present benefits for packing operations. However, their experimentation simplified the components of the object tracking system by assuming that the operator can memorize the position of cargo before the process begins, or by using markers to resolve the location of objects. With this in mind, we have defined our initial goal in the field. So our initial goal was to get an insight in the augmented reality assistance for packing operation with focus on visual tracking algorithms. To address this goal, our strategy consists in formulate a systematic literature review that allows identification and analysis of available algorithms that tackle the tracking of a target object by using visual approaches. We bound the scope by defining 3 specific goals that I'm going to address in the next sections. So let's pass to the methodology. The first step was to define a set of questions related with our main goal. We have 3 questions. The first one, what are the tracking algorithms in the context of augmented reality and packing applications? The second one, which business process has motivated the design of those algorithms. And the last one, what are the research gaps? The second step was to define a search strategy. This strategy was composed by three elements: the search string, as you see here, the inclusion criteria, and the exclusion criteria. Finally, we define a selection procedure. In our case, this selection procedure is divided in two steps: preliminary selection and final selection. After performing all these steps, we selected 30 documents to analyze and to resolve all the main questions of our research. Let's go to the results and discussion sections. To answer the first question, we have conducted a classification of the identified algorithms as is presented in this figure. The figure divides the set of algorithms into 7 categories with diverse density. To be more concise, we can reduce the number of groups to 3 groups: the region-based here with 12%, the SLAM direct-based with 27%, and the others under the name of future-based with 61%. To address the second question, we have grouped the business processes into 7 categories as presented in this figure. This graph highlights that most of the selected algorithms were related with augmented reality, in assembly, in maintenance, combined with mobile robotics, or in generic applications. Additional findings show that all algorithms report validation through experiments in public, private, and hybrid databases, but no one reports tests on the field on the real industrial application. Also, none of the validation were performed in a packing scenario, as the one that we have described. Finally, to identify the gaps in the area, we have made an analysis between the requirements of the visual tracking system and the performance of the selected algorithms. With this analysis, we built this bar graph. On the left, we put the requirements identified for the process, and the bars, these bars, indicate the percentage of algorithms that have addressed each requirement. As you can see it in the figure, all the requirements with less than 72% have been highlighted, and this has been marked as the research gaps in the specific area. So let's pass to the conclusion sections. We have 4 main conclusions. Initially, that the visual tracking of objects for packing application is still an open problem. Secondly, there exists a lack of initiatives to validate the performance of these algorithms in the field in the real warehouses. In the third conclusion, we have that there exist at least 6 research gaps in the area of visual tracking of boxes for packing, as we saw in the bar figure. And finally, based on the performance and based on the fundamentals of operation, we highlight 2 of the 7 types of algorithms as the ones with more suitable conditions to resolve all the requirements for packing operations. These 2 are trackers based on SLAM Direct and trackers based on SLAM-based futures. So that brings me to the end of my presentation. We looked at 4 main points: the introduction, where I present the problem and localize the problem; the methodology, where I presented the steps that we performed to resolve these questions; the results and discussions, where I presented all the features and trends that we have found after analyzing the documents; and the conclusions. Thank you very much for your attention, and if you have any questions, I will be happy to answer them now.